last example for 1.4 here is a real world example talking about, a tournament. It's a Scrabble tournament, which doesn't really make a difference. If it was any other tournament, we could do it the same way. One of the tricky parts about questions like this is understanding how to apply it to a geometric series. So right off the bat, it tells me that there's 256 people entered into this Scrabble tournament, and each round is going to be kind of a head-to-head, and the loser is eliminated. So in round one, I'll just put R1. Well, let's do T1, because after all, we're going to talk about a sequence in a second here. So the first term, there's 256 people, which I hope logically means, and I'm just going to write matches down here, that if there's 256 people and the matches, I'm just going to put 1v1, we know then that there's going to be 128 matches. All right, now after those 128 matches, half of these people are going to be removed. So the next round is only going to have 128 people, which means my next round is only going to be 64 matches. Then 32 matches, then 16 matches, then 8 matches, then 4 matches, then 2 matches, and then finally 1 match. Now, it's important that we know not to go any further. We're not going to put in 0.5 or 0.25 because that series is representing the total matches being done. That is over when there's 1 match. After that match, there's 2 people remaining, and so those final 2 people are they're just going to determine the winner of this Scrabble tournament. Now, certainly in real life, this may be more complex if the third place plays the fourth place for bronze or silver or whatever it is, but that's not what this question is. All right, this is just a head-to-head until the last person standing gets the whole person. I'm sure there is some kind of money involved in a Scrabble tournament. So we need to find out the total matches played. So what I need to do is add these numbers together. Now, most students will look at this and think, wow, this is a joke. I can just actually type in. I mean, there's only 8 numbers there, right? I can add 8 numbers, that's especially with my graphing calculator. And I mean, you're not wrong. You could just add these numbers together. But what if there's, what if it's a international Scrabble tournament and there's 2 million people, they're doing it online? You are not going to want to add that many numbers. So just like in sections 1.1 through 1.3, although some of these questions you can brute force by actually adding the numbers together, you want to try to focus on the formulas because that's going to build that competency at using these, which allows us to not take quite so much time to determine things that algebraically we can do a little bit easier. And in order to do that, I am going to identify that the first term is 128, the common ratio is 0.5, and the last term is 1. Now, I would like the option of using either formula, so I'm going to write underneath here that this is term 1, term 2, term 3, term 4, term 5, term 6, term 7. Term 7 got a little away from me, and then finally term 8, which means I could also put, and I'll put it in red to be consistent, that n is equal to 8. Now, there's certainly no reason to do this in a question, but I want to show you how both of these formulas will result in the same answer within, the same problem, of course. And we do have enough information to use either formula. So I'm going to do both. I'm going to first say that the sum of these 8 terms is equal to the first term, 128, times the common ratio of 0.5 to the power of 8 minus 1, all divided by 0.5 minus 1. And just like I did previously, I'm going to write the value of the numerator and the denominator. And I hope that allows you to check via your calculator whether you can do this correctly, because you need to make sure you can. And I get negative 127.5 for the numerator value and negative 0.5 for the denominator value. Just ran out a little bit of room there. And I get that there are 255, and I'll put matches there because that really is the total number of matches being done. Now, assuming we've done this correctly, and I think we have, I should be able to get the same number using my other formula. I'm still going to write S8, but with the other formula, I'm going to take the common ratio of 0.5, and I'm going to multiply it by the last term, which is 1, and I'm going to subtract the first term, which is 128, and that's going to be divided by the common ratio of 0.5 minus 1. So just to be clear, I'm doing this formula right here in blue. When I use those values and I determine the numerator and the denominator separately, we're going to see something pretty important happening here. I am going to get the same expression, right? 0.5 minus 128 is negative 127.5, and 0.5 minus 1 is negative 0.5, and we get 255 matches with both of these formulas. Now, again, please don't start doing questions with both. You do not need to prove that they're both valid. We know that. We've known that for a few hundred years. But I really do think it's important for you to see that it truly doesn't make a difference. So what I would recommend doing is what I've done in red, identifying the values we know, and I mean, maybe the values we don't know as well. It's not a bad idea to write that S8 is what we're looking for there. And then you can choose the appropriate formula that is going to involve basically the easiest technique to go from the question to the solution. All right, so I'm going to put up the full assignment on the board. Please do check Google Classroom. We are modifying them. And as always, good luck. If you're having problems, please do email for extra help.